Hey everyone, it is Mr. Russell here on this fantastic Wednesday to talk to you guys about the volume of a pyramid. Hope you all had a great day yesterday and had an even better Memorial Day weekend. Happy official kickoff this summer. We are in the home stretch, folks. The home stretch here. I hope you're all doing well. If you have any issues with anything, any questions, please again don't hesitate to send any of us an email and we will help you out as soon as we can. All right, so let's dive headfirst into these pyramids. First of all, guys, I really hope you appreciate how great this background is. Man, I just love this. Got the beach going on, nice waves, blue sky. Snoopaloop over here is just chillaxing. Man, living his best life. Very jealous of Snoopy over there. All right, but let's get back into geometry. So, Ms. Ophianos last week talked to you guys about all these different three-dimensional shapes. And we're going to focus today just on the pyramid. So just to kind of bring some of the important parts back. A pyramid could have two different types of heights. Okay. Now, one is the official height of your pyramid. And that's the one you guys see here that goes from the very top or the vertex and then drops down right into the middle of your base. It actually ends up being perpendicular to that base. Okay. So again, from the vertex straight down right into the middle of the base. The slant height on the other side is one that lies along like the sides of one of the pyramid of your pyramid. Okay. Or we say it lies on one of the lateral faces of that pyramid. Can you see that here? It's marked with the cursive L. So we have a slant height on the side of our pyramid and the official height or just height that goes from the vertex and drops down and is perpendicular to the base. It goes right to the middle. So for us, when we find volume, we're going to need to know what the height, so the one in the middle here, is of your pyramid. If we had done surface area, and that was something we had to take out of this unit, because just time's sake here, surface area is like if you were to wrap a present, or if I was to wrap that pyramid in wrapping paper, you would use the slant height to find the surface area. Okay, that's what we would need in this case, this one here. But we're just doing volume, so again, we're focusing on what the height is. But we have a problem sometimes. Sometimes we'll be given an example like this, where it won't tell us what the height of our pyramid is. It'll give us the slant height and say, all right, well, hey, have at it, go find the volume. So we have to use our incredibly brilliant geometry skills to figure out a way that we can find out what the height of this pyramid is, okay? So I'm looking at this, and I say, all right, well, you guys can see that we have a right triangle that's formed inside of here. That's made up of the slant height, the real height, or the actual height, and then this piece right here. And this is kind of interesting. If I'm looking at this, there's a way we can figure out how long this side length is. I'm being told or being given that the side of our pyramid is 12 inches. So if this height is going from the vertex and goes right into the middle of that base, that means that the length of this side here is going to be half of whatever the length of the side of the pyramid was, okay? So that really helps us out because now we can go ahead and say, well, this length down here is me half of 12, which is 6. So you can put 6 down here. And now we're going to go ahead and look at this right triangle and think back to chapter 8, guys. What is the most famous theorem? We've talked about it a bajillion times. How can we find a missing length on a right triangle when we already know two sides? I hope you're saying in your head, it's the Pythagorean theorem. We're going to use Pythagorean theorem, we're going to figure out what our height is, okay? So again, Pythagorean theorem is hypotenuse squared equals leg squared plus leg squared. The hypotenuse is always the one opposite from the right angle. So if here's my right angle, opposite from that here has to be the hypotenuse, which is 10 inches. Okay, so I'm going to start setting this up and say, all right, well, to find my height, let's use Pythagorean theorem and say 10 squared, because that's the hypotenuse, is equal to h squared plus 6 squared. Oh, yeah, look at that handwriting. My God, it's beautiful. Okay, and let's simplify. So we get 100 is going to equal h squared plus 36. We want to solve that for h, so let's go ahead and subtract 36 from both sides. Let's get that thing out of here. Minus 36. Okay, cancels out. So 100 minus 36 ends up being 64. Okay, equals h squared. And then how do we undo squaring something? Square root. So we're going to take the square root of both sides of my equation. Because when you square root a square, they undo each other, which will leave me with just h on the right-hand side. And we find the square root of 64, which is really nice because 64 is a perfect square. And the square root of 64 is 8, or 8. Okay? Okay, that's a big thing. That's a big thing for this topic. Okay, so let's apply that. So first, let's look at this one. Sorry, I got to tell you guys about how to find the volume first, I guess. Okay. So when it comes to find the volume of a pyramid, okay, what we're actually going to do is compare a pyramid that has a base that is congruent to a base of a prism. Okay, so let's say these two ones, they both have congruent bases, and they have the exact same height. Okay, there's a video I want you guys to watch that will compare those two volumes for you. So here's what you're going to do. When I tell you to, you're going to pause this video. On the P-Learning page on the right-hand side, there is a video. It says task number 3, and it says comparing the volumes of prisms and pyramids. Okay, so when I say so, I want you to pause this video and go click and watch that video. It's only 2 minutes long, it's super quick, and it does a really nice job visually showing you guys how the volumes compare. Okay, go ahead and pause now. Okay, welcome back. Okay, you should have just watched that video. When you did that, you saw that it took 3 pyramids, okay, fill them up with water, or I think it was like those little like spheres, and fill it into the prism. It took 3 of those to make that happen. So therefore, the formula for the volume of a pyramid is 1/3 base times height. You know, area of the base times the height was the formula for the volume of a prism. We're going to multiply it by 1/3 because that's 1/3 as big. Okay, now you notice how capital B, again, is the area of the base. To keep it easy, guys, we're only going to find the volume of square pyramids. So this capital B here will always be us finding the area of the square base. All right, and then H is the height, which is the one that goes from the vertex, the very top, straight down, and is perpendicular to the base. All right, that's what we need. Area of the base times height, either multiply it by 1/3, or you can then go ahead and divide it by 3. Those two things mean the exact same thing. So let's do a couple examples. So here's our first one. Okay, I want to find the volume of the square pyramid. So I'm looking at this. All right, I see it's a square pyramid. So if this side here is 40, I know every other side would also have to be 40 feet. And it's 25. Well, is that 25 the height of our pyramid? Nope, it is not. That is the slant height. This is just like the example from before, guys. We have to go ahead and figure out what is the height of our pyramid first. Okay, we're going to go ahead and use Pythagorean theorem for that. But first, since the height goes right into the middle of our base, we know this length down here is going to be half of one of the sides of our base of our pyramid. Okay, so since one side length here is 40, half of that will give us 20. So let's go ahead and figure out the height of this. So we're going to use Pythagorean theorem. Hypotenuse squared equals leg squared plus leg squared. So 25 squared is going to equal 8 squared plus 20 squared. Okay, so 25 squared is 625. 8 squared plus 20 squared is 400. Let's subtract 400 from both sides, and we'll get 225 equals 8 squared. Okay, we want to undo that square by square rooting both sides, and the square root of 225 is 15. So our height is 15. The other thing we need to find the volume of a pyramid is the area of the base. Okay, so we're going to go ahead and find the area of the base. That beautiful thing, guys, is since it's a square, you know, area of a square is just either side length squared, or you think of it as length times width. So my area of my base here is just going to be 40 times 40, which is 1600. So let's go ahead and put it all together. So now we can say volume is going to equal 1/3 area of our base, which we just found over here, right, is 1600, times the height of our pyramid, which we found using Pythagorean theorem, is 15. Multiply all together, which you could do as multiplying 1600 times 15, hit enter, then divide that by 3. Or if you have the calculator or the fraction function on your calculator, you can plug in 1/3 and multiply it by 1600 times 15. Regardless, though, you should get a volume of 8,083 and it's three-dimensional space, so it's feet cubed. Okay. Beautiful, guys. Beautiful, beautiful, beautiful. That's the hardest it is. That is the absolute hardest type of example I'm going to give you guys. So to try to keep it a little bit shorter, I'm just going to go ahead with 2 U tries now. Okay, so pause this video real quick. Try both examples out, and I'll go over them once you finish. Go ahead and pause now. Okay, hope you guys did a nice job on those. So for the first one, you should get 66.7 feet cubed. And for the second U try, had to use Pythagorean theorem to find the height of your pyramid. You should get a volume of 240.3 yards cubed. Now the rounding there might have thrown you off on that second one, but we'll go over that right now, okay? So for the first one, it's pretty straightforward because they already gave us the height, right? See how the height goes right into the middle of our pyramid? So that is the height we need for volume. So it was all we had to do was first find the area of the base, okay, which is a square pyramid, so it's just 5 times 5, which is 25. So then volume was 1/3 times the area of the base times the height of the pyramid. Okay, so then 25 times 8, that divided by 3, or 1/3 times 25 times 8 will give you, let's round to the nearest tenth, guys, so 66.7 feet cubed, or cubic feet. All right. And for my second one, we had to use Pythagorean theorem first to find out what the height was. I know it wasn't drawn in here, but you can see is how this height here goes to a side length and is not going to about the middle of your pyramid, right? So that right there would be the height. So you see how it kind of forms that nice right triangle. So we have to use Pythagorean theorem first. So this one was cool. It's drawn a little differently than the last one I had given you guys. So let's go ahead and do that. So first of all, the length over here is going to be half of whatever the length of one of the sides of our base is. So since that's 9, half of 9 is 4.5. So that length, oh, I just erased it. Come on, Mr. Russell, is 4.5. So Pythagorean theorem says to multiply or take h squared, hypotenuse squared, it's going to equal leg squared plus leg squared. So 4.5 squared plus h squared. Okay, so 10 squared is 100. And that's going to equal 4.5 squared, which is 20.25 plus h squared. So we're going to subtract 20.25 from both sides of our equation. So 100 minus 20.25 is 79.75 equals h squared. Okay, let's square root both sides. And that will give us a height. This is where I rounded. Okay, I rounded to the nearest 10th. And my height was 8.9 yards is my height. So then for our volume, first of all, we need area of the base. So area of the base, since one side, according to this figure, is 9, it'd be 9 squared, or 9 times 9, which is 81. Okay, so then for volume, let's go ahead and plug this all together. So volume is going to equal 1/3 times the area of the base times the height of our pyramid. Ooh, I'm out of room. Oh no. Jeez. We'll pretend there's a 9 there, right? 0.9. Good enough. Okay, so 1/3 times 81 times 8.9 is going to give us, again, rounded, volume is going to be 240.3 yards cubed. There we go, guys. Okay, please let us know if you have any questions. Your next task is to complete the lesson check, which is you can find by following the link to the Google form on the right-hand side of your P Learning page. Okay, let us know if you have any questions. If not, I will talk to you guys tomorrow. Have a good one.